Previously, we learnt about the family of straight lines, where when two straight lines intersect each other, the infinite number of lines passing through that same point can be shown by the equation L1 plus lambda L2 equals 0. Today, we will learn the family of circles through the combination of a circle and a straight line. Let's take this circle S, whose equation is x squared plus y squared plus 2gx plus 2fy plus c equals 0, and this straight line L, ax plus by plus c equals 0. Now, consider the equation S plus lambda L equals 0, where lambda is a parameter. When we substitute, we get x squared plus y squared plus 2gx plus 2fy plus c plus lambda into ax plus by plus c1 equals 0. So when we rearrange this, we get x squared plus y squared plus 2g plus lambda a into x plus 2f plus lambda b into y plus c plus lambda c1 equals 0. This equation has x squared and y squared terms with equal coefficients. Also, there is no xy product. So, it is safe to say that this is an equation of a circle. This means that when lambda varies, we get a family of circles. So, the family of circles formed by the combination of this circle and straight line is given by the equation S plus lambda L equals 0, where lambda is a parameter. There are three main situations for this family of circles. So, the case 1 is when the circle and the straight line intersect each other. So, in this case, let's say that we have this black circle and this black straight line. Let's say that the straight line intersects the circle at the points P1 and P2. Using the equation S plus lambda L equals 0, we can obtain the family of circles. Here, the brown circles represent the family of circles. So, all these circles will have one common characteristic. They will all pass through the points P1 and P2. So, when a circle and a straight line intersect each other, the family of circles pass through the points of intersection. So, when a circle and a straight line intersect each other, the family of circles pass through the points of intersection of the original straight line and circle. Now we come to case 2. Here, when the circle and straight line touch each other. So let's say that the circle and the straight line touch each other at the point P. This means that this straight line is a tangent to this circle. The common characteristic of all the family of circles is that all these circles will also pass through the point of contact P. So, when the circle and straight line touch each other, the family of circles pass through the point of contact. Now we come to case 3. Here, when the circle and straight line do not touch or intersect each other. So in this case, this black circle and this black straight line do not touch or intersect each other. So the common characteristic of the family of circles is that they also do not touch or intersect the circle or straight lines. So when the circle and straight line do not touch or intersect, the family of circles also do not touch or intersect each other. So to understand how to solve a question, let's take this example. Here we are given a circle S, x squared plus y squared plus 8x plus 2y plus 8 equals 0, and a straight line 6x minus 8y minus 1 equals 0. We are told that this straight line intersects this circle S, and we are asked to find the equation of the circle whose center lies on the line 2x minus y minus 1 equals 0 and passes through the points of intersection of S and L. So here we can understand that the circle they have asked us to find belongs to the family of circles, because here it is mentioned that the circle passes through the points of intersection of S and L. So now let's take our equation S plus lambda L equals 0. So here when we substitute the values, we get x squared plus y squared plus 8x plus 2y plus 8 plus lambda into 6x minus 8y minus 1 equals 0, where lambda is a parameter. So when we rearrange this, we get the equation x squared plus y squared plus 8 plus 6 lambda into x plus 2 minus 8 lambda into y plus 8 minus lambda equals 0. So this is the common equation for all the circles passing through the points of intersection of S and L. Now we need to find the equation of the circle whose center lies on the line 2x minus y minus 1 equals 0. So from this equation, we can find the coordinates of the center of the circle. So for that, we have to divide 8 plus 6 lambda by minus 2 and 2 minus 8 lambda by minus 2. So we get the common center of all the family of circles as minus 4 minus 3 lambda and 4 lambda minus 1. Now we want to find the circle whose center lies on the straight line to x minus y minus 1 equals 0. So what we do is we substitute these coordinates of the center into this equation. So that would be 2 into minus 4 minus 3 lambda minus 4 lambda minus 1 equals 0. So finally we can find lambda equals minus 4 upon 5. So now we substitute this lambda value into this initial equation. So then we get the equation of the circle as 5x squared plus 5y squared plus 16x plus 42y plus 44 equals 0. So that's how you use the family of circles equation. Now for the tip of the day. In our first case, we saw that when the circle and straight line intersect each other, the family of circles also pass through the same points of intersection. A very common question that is asked is to find the smallest circle passing through the points of intersection. In this case, we don't have any direct data about the circle such as the one given in this example. So, what we do here is we need to understand that the smallest circle will be the circle whose diameter extends from P1 to P2. That is, the points P1 and P2 will be the diameter of the smallest circle. So this means that the center of the smallest circle will also lie on this straight line that is given. So now using this information, you can find the equation of the smallest circle. So to understand this concept even more, try answering the questions given in the description below. The answers are also given for your reference. Until we meet again, take care.